Let's try to solve this problem over here. So you have a gas that goes over a cycle of A, B, C, and A as shown in the figure above, whereas C and A is an isothermal and A to B is an isobaric. So we can go through process together. So it starts from A to B. So A to B, what happened here is pressure is kept constant. So it's an isobaric kind of process. And because the volume decreases from 25 liter to 5 liter, it's an isobaric compression. Okay, from B to C, you can see that the volume is kept constant at 5 liter, whereas the pressure is increasing. So for this one, we know that volume is constant, is an isovolumetric process. So isovolumetric process, but at the same time, you know that the pressure is increasing. Then from C to A, you can see that it's going down on the curved line. And because they tell that it's an isothermal process, it is happening on an isotherm. So the temperature is being kept constant. But at the same time, you see that the volume is increasing from 5 to 25. So this is an isothermal expansion. Okay, it's an isothermal expansion. So let's probably write down, construct our table like what we did as usual. So we know that you go from situation A, you go to situation B, then from situation B, you go to situation C, then you come back to A. So from A to B, what happened here is that you can see that the volume is decreasing, so it's a compression. At the same time, you know that the pressure is kept constant, so this is an isobaric compression. Okay, then after that, you go from B to C. From B to C, you see that this is an, what do you call it? Volume is kept constant, so this one is isovolumetric. But you might be not sure whether it's heating or cooling for this case, but it's actually heating because it goes from one lower isotherm to a higher isotherm. You can think of it like this. Okay, let's say you can think of it like this. There's an isotherm over here. There's another isotherm over here. Okay, so this one is temperature. This one, let's say, is temperature 2. This one is temperature 1. We know for sure that temperature 2 is greater than temperature 1. So because you go from here to here, this is definitely a heating process because you are causing a temperature to increase. So this is an isovolumetric heating process. Then after that, you go from C back to A. The pathway that you go from C back to A will be called as isothermal. So this is an isothermal process because it says so in the question. Then after that, you know that the volume is increasing. So this is an isothermal expansion. Okay, so let's write down the pressure, volume, and also the temperature. Okay, pressure, volume, and also the temperature. Pressure, volume, and also the temperature. Okay, so we know that the pressure of A is 50 kPa, so 50 times 10 to the power of 3 Pascal. The volume at A is 25 liter, so 25 convert to meter cube times 10 to the power negative 3 meter cube. Temperature unknown because it's not indicated in the graph. Next, for state B, your pressure is 50 kPa, 50 times 10 to the power 3 Pascal. The volume will be 5 liter, 5 times 10 to the power of negative 3 meter cube. Temperature unknown. Okay, then you go to state C. The pressure is unknown, but the volume is 5 liter. So volume is 5 times 10 to the power negative 3 meter cube. Temperature unknown, but the pressure also unknown. Okay, so we have listed down the information that we know. Now what do? We relate between each process. What law can be used? Okay, from A to B, because pressure is constant. That's why our equation will not have pressure inside. It will be V over T is equals to V over T. So this is VA, TA, VB, TB. Okay, continue from B to C. From B to C, you can see that it's isovolumetric, so volume is constant. So if volume is constant, for this case, it will be P and T because you cannot have volume in the equation. So P over T, PB, TB, PC, TC. Then let's continue from C to A. From C to A is isothermal, so T is constant. So T is constant, therefore you can say that PV is equals to PV. So PC VC is equals to PA VA. Okay, so that's how you determine what equation can be used. So right now they ask you to find the pressure and volume for coordinate C. So pressure and volume for coordinate C, you just need to find pressure. So to find pressure, you can relate between B and C to find pressure C. Okay, so we are going to use this equation over here for question A. For question A, you are going to use PB over TB. Okay. Oh, so sorry. No. You are not going to use this direction. This is probably not the wise choice, not the wise choice. What you're going to do is you have information. You have more information on this side over here because you have pressure and volume. It's more suitable to use Boyle's law. So Boyle's law, most probably you should relate C and A instead of relating B and C. Because if you relate C and A, you're able to use Boyle's law. You have the pressure and volume, so you don't need to purposely go find temperature. If you use B and C, you can still find the answer if you use B and C, but you have to go find the temperature first. So to find the temperature, you have to find this temperature first, then you find this temperature, then only you work this way out. But if you go from C to A, it's a direct relation using Boyle's law. So you can use PCVC is equals to PAVA. Okay, so I think most of the things is in the table. So V is times 10 to the power negative 3, 5 times 10 to the power negative 3. Pressure A is 50 times 10 to the power 3. Volume is 25 times 10 to the power negative 3. So from this calculation, I believe you'll find the answer to be equals to 250 times 10 to the power of 3 Pascal. Okay, so that's the pressure at state C. So if you want to find the PV coordinate at C, that will be PCVC. So the coordinate will be 250 times 10 to the power 3, that's the pressure, Pascal. Then your volume C, you just copy from the table, 5 times 10 to the power of negative 3 meter cube. So this is your PV coordinate of C. Next, for question B, what is the work done for the isobaric process? Isobaric happens here. It happens between A and B. So A and B, between A and B, this is the line. You are going to find the area under the graph from A to B. So this is the area that we are finding. But again, you have already derived the equation. So you can just use the equation that you have derived from the concept lesson. Okay, so for isobaric, you know that the work done from A to B equals to pressure, then it equals to volume final minus volume initial. Okay, pressure from along A to B will be the same. That's 50 kilopascal, nothing to worry about. So you can label it as A, you can label it as B, both are fine. But the final initial is actually not so appropriate to label as final initial. You should probably look at the process. You know that it goes from A to B. So A is initial, B is final. So if A is initial, B is final. So this will be VB minus VA. Because you go from initial, which is A, to final, which is B. Okay, so right now, pressure here will be 50 kilopascal. Then volume B is 5 liter. Volume B is 5 liter. 5 liter converted is 5 times 10 to the power negative 3. You have to convert. You cannot do it in liter. If you do it in liter, you will not get answer in joule. Okay, so make sure you convert everything to the proper unit, which is Pascal, meter cube, and Kelvin. Okay. We continue minus the volume of A. Volume of A, 25 times 10 to the power negative 3. Okay, so if you put everything into your calculator and you find the work done, your work done will be a negative value, I believe, which is negative 1000 joule. Okay, why is it a negative value? Because if you look over here, it is a compression. So compression means by the outside, the surrounding is pressing on the system. So it's work done on the system. Work done on the system is a negative value. That's why you can get negative work done over here. Okay, next, what is the work done for the isochoric system? Isochoric system, where is isochoric? Isochoric is the same thing as isovolumetric, so that's BC over here. So B to C, they're asking for the work done. But I believe you can notice that from B to C, there is no area under the graph. Because technically, there's no change in volume that happens during isovolumetric process. Isovolumetric, same volume. There's no change in volume. There is no work done. For work to be done, you must have change in volume. But if there's no change in volume, the work done will be equal to 0. So question C is simple. The work done from B to C will just be equals to 0. Okay, lastly, what is the heat involved in the isothermal process? Heat involved in the isothermal process, well, you have to bring back out the first law of thermodynamics, Q minus W. Again, for isothermal, temperature does not change, so the internal energy won't change. Okay, you can refer back to the equation, delta U is equals to F over 2 and R delta T. So if my delta T is equals to 0, my delta U will be equals to 0. Okay, so in this case, Q is equals to W. So what I need to do is just to find the work done for the isothermal process, and the work done for the isothermal process will be equal to the heat involved. Okay, so W here for isothermal process is C to A. So we are finding work done from C to A. If you expand it, it will become nRT ln V final. Final, we go from C to A, so A is final. Divide by V initial. Initial is C, so you go from C to A. Okay, so this is the equation. Technically, you can pick any temperature in between C to A because it's the same temperature. But I believe you are aware that we don't have number of mole over here. So because you don't have number of mole over here, we might need to replace this nRT over here using ideal gas equation. We can replace nRT over here with PV. Okay, then technically you can replace it with PCVC, that's fine. You can also replace it with PAVA, that is fine as well. Okay, both are accepted because why? Because this is an isothermal process, the temperature will be the same. Okay, so let's replace it with pressure A, volume A maybe, PAVA ln VA over VC. Okay, so now you can proceed with your substitution. Pressure A is 50 kilopascal, volume A is 25 millimeter cube. Okay, then you have a ln VA is 25 times 10 to the power negative 3. Sorry for the poor space management. VC is 5 times 10 to the power negative 3. Okay, so substitute everything in. I believe you calculate it, you'll get your Q to be equals to 2012 joule. Okay, so this is the heat that flows into the system. It is also the work done by the gas system during this process going from C to A. Again, work done is positive here, means that it's work done by the system. Work done by the system means by the gas is doing work. How does the gas do work? By pushing the container wall. By pushing container wall means by it is expanding the container. So you see from C to A, definitely you see the volume increase. Okay, so that's how we determine the heat. Always, if it's involving heat, right, you have to come back to your first law of thermodynamics to find the relationship between work and heat, and from there you can determine everything. Okay, so that's it for this question. Thank you very much.